documented, which makes it funny later. Yeah. Didn't make it up. Okay, so. 7.1, I don't normally teach. This is 7.1. So this is your review of that. Because it's done in chapter 4 and 5.
No.
I see that. So perhaps. Like I printed this 10 minutes ago because I know that they changed it.
Still.
Right here, not on my nose either. I need 12. All right, so let's look at this. Gave you a pretty simple equation for velocity. Gave a time span. Ari, how do I determine when the particle is moving right, left, and stop?
You just find it when you say it equal to 0, and then you do a little number line thing, and then you see when it's positive or negative, and you see when it equals 0, that's when it stops.
So what time does it equal 0?
5.
So it stopped when velocity is 0. We said make a number line. What numbers do I put on?
0, 0, 5, and 9.
Okay. So it's a good idea to put the restrictions on there. So plugging in 1, I get a positive. Plugging in 6, I get a negative. So Nina, when is it moving to the right?
From 0 to 5.
And Miriam, when is it moving left?
From 5 to 9.
5 to 9. Okay. Sydney, how do I find the particle's displacement?
You need to find the integral of velocity from 0 to 9.
Find the integral of velocity from 0 to 9. So raise the power, divide by the new power, and evaluate from 0 to 9. So 90 minus 81 minus 0 is 9. Do I have units? Meters. Fiona, what about part C? If S of 0 equals 3, what's the final position?
Is that like where you do the like linearization or is that something?
It's not a linearization. Cecilia, do you know?
Do you like do the integral plus C and then plug in 0 and 3? And you get C equals 3.
So that question is really asking, do you understand what integral gives you? So you said that the answer to part B, you guys calculated the displacement, how far you are from where you started, that's displacement. You were 9 meters ahead of wherever you started. Where did we start? So your end position is where you started plus the displacement. Jasper, what's the difference between part B and part D?
Total distance is like if you go backwards, it's still distance.
Okay, so the squirrels were in a Fitbit, so if you're traveling backwards, you're still traveling. Okay, so how does that change how we do this problem?
You have to find like the integral velocity from 0 to 5, and then ask about.
So integrate from 0 to 5, and that we calculated here, it's positive. Okay. So from 0 to 5, that's 50 minus 25 minus 0. So the first 5 seconds, we went 25 meters forward. And then you said, how do I deal with the negative? Or the other section?
Absolute value.
Okay. So I'll integrate from 5 to 9 and I'll change the sign. And maybe minus 81 minus 25 that we got a second ago. So 16. So our Fitbit's gonna say we traveled 41 meters. Okay, so this is all 7.1 is do you understand the difference between displacement, total distance? Can you still interpret when the rate of change is negative, you're going backwards or you're losing stuff? When the rate of change is positive, you're traveling forward or you're accumulating things. All good? That's the big review. Okay. How many of you are leaving early for spring break? Okay, at least you know now. To not have the snow incident of the chapter 6 test forever moving. As it is, the chapter 9 test is just before spring break. It is not good to let you go away and come back to chapter 9 after break. So we are very much going to get that test in before that. And so those, if you didn't pick up a new calendar, there's a new one over here, which is just one page. Get one already? Hi, get one or? Anyone not get one? And I might be stealing a day from chapter 8, because chapter 8 is just chapter 9 with another name. So very much have the target of getting that test in before break. Chapter 10 is just about a week. We'll do that after break. And then we have fourth quarter. In fourth quarter, you will have, I call them 4 tests, but goes in the grade book, or it's over 5 days, but it goes in the grade book as 4 tests. and it is an actual AP exam. And we'll do the multiple choice without calculator, which is an hour, which means I'll ask you to come in 15 minutes early one day, so sorry. There's multiple choice without calculator, which does fit in an actual class period. And then there's the free response questions. There's 6 of them. You generally get about 15 minutes per question. The first 2 are with calculator, the last 4 are without. And we will do some others as practices, and you should be well versed at what these tests look like. And I grade them. I will put the raw score in the grade book, and it'll say not for grading. And if you have any letter other than an E, you are so solidly in for a 5. So warn your parents this is coming. Yeah, Mom, I got an E. That's good. Like, I got a 55%. Rock it, because you are. So then there will be the curved score that is curved to the AP grading, and you will be much happier with the way that letter looks. Okay, so that's 4th quarter. And I was just told Friday I'm not allowed to do my normal thing, which if your 4th quarter grade is lower than your AP score, like the idea is if you have an A in here, you're going to get a 5. If you have a B in here, you're going to get a 4. And students, if you got a C but you got a 5 on the exam, I would change your 4th quarter grade. Not the semester, but just 4th quarter. I was told I'm not allowed to do that. It doesn't normally affect many people, but I was informed I'm not allowed to do this. So if you heard that from other people, I'm not allowed to do that anymore, and I'll have to get creative on stuff. Anyway, so that's 4th quarter. Just letting you know what's coming. Does it actually say day 81 is the first day?
Yeah.
Cool. And if you wanted to look at the textbook of stuff on 7.1, page 371, there's problems related to what we just did on the warm-up. Not a big deal. And tonight's homework, every other odd, so you don't have to do all of them. It's really not that many. All right, so we're gonna do area between curves. So suggestion, how would I find the area of the pink fish belly? Ethan?
Find the area under F, we go minus the area under G.
Find the area under F and subtract the area under G. How do I find area?
Straight.
Exactly. So here's the idea, exactly what Eitan said. Top curve minus bottom curve over the slice that you were looking for. Back to the rectangle thing. If you were to do rectangles, it's just finding chunky rectangles like that. More on the rectangles. I hate the partition notation. Okay. Massimo, what about this situation? How would I find the area between the curves?
You would have to look at each piece. So it would be the integral of f of x minus g of x from a to b, and then it would be g of x minus f of x from b to c.
Okay. So you might have to look and see the top curve isn't always the top curve. So from A to B, it's pink minus black, and from B to C, it's black minus pink. That's all. Some of these would be calculator questions because it's hard to find the intersection point. But do you guys know how to use a calculator to find the intersections of curves? very little reaction, like 5 of you are like, yeah, and the rest of you are like, what? Okay, let's see. So, right here, you don't need a calculator for this one. But draw it, set it up, give it a try. You said you didn't need a calculator. How do we find the intersection points? Graded? How'd you get that?
This was the same as you just.
Okay. Some of you just see this, you know this from the unit circle. Strictly looking, maybe you don't know. And normally we tell you never, ever, ever, ever divide by something that could be 0. So I need to check in my answers here. In the end, I gotta make sure cosine isn't 0. But do I know where tangent's 1? That I know from the unit circle. Pi over 4, 5 pi over 4. How come I'm not taking the 5 pi over 4? The restrictions on the given problem. Okay. Oops, sorry. Grady says that intersects at pi over 4. Don't know that I need the y value, but here we go. Pi. Nick, what do I set up to find?
Set up the integral of sin x.
What's the, I didn't draw them well. What's the top curve, what's the bottom curve?
The top curve from 0 to pi over 4 is sin x. But like that's like half of the slice.
Okay. Okay, thank you for reminding me. Okay, in this we need to look at all the givens. Find the area of the region bounded by cosine x. Cosine's the pink curve. So bounded by cosine x, sine x, and x equals 0. X equals 0 is right here. So the region that we're finding is touching all 3 of these things. As Nick is pointing out, well, there's this section, and then this, like, they cross an infinite number of times. I don't want to find all of these bubbles. And how did I restrict that? I said x had to equal 0. And finally, after 15 years of having to say it, I put it on the paper. If I don't say x has to be greater than 0, technically that space also touches a cosine, sine, and x equals 0. But I said I wanted the positive region. So Preston, how do I integrate, oh, what are the boundaries I should put on there? 0 to pi over 4. Sean, what is the integral of cosine x?
Sine x.
Josh, what's the integral of negative sine?
Negative sign, negative cosine. Or
Positive cosine. Okay, so Miriam, sine of pi over 4? Root 2 over 2. Jamie, cosine of pi over 4?
It's also
So I have 2 of those. Minus the zeros. Hannah, sine of 0?
0.
And Hadley, cosine of 0?
1.
So the area trapped between the curves, root 2 minus 1. Is that positive or negative? Positive. Root 2 is bigger than square root of 1, so it's going to be something positive. If you're finding area, actual area, it should never be negative. You want to know how much paint is required to color in that space, it should never be negative, even if it's below the x-axis. If you got a negative, you probably have your things upside down.
I understand like why you don't want the negative x because like you could explain that, but I don't understand like why you don't want more of the positive.
Um,
Going for it.
Okay, it needed to hit cosine, sine, and x equals 0.
Oh, physically hit the.
Physically
Yeah.
hit that line. So that's the challenge. X equals 0 in this case is a line, it's not just the coordinate, it's the equation of the y-axis.
So after that first intersection, the rest of it doesn't count. So it doesn't
Right.
hit the 0.
Because all those little bubbles, I don't care, doesn't touch that one. So the hard part is pulling out the restrictions. Okay. Try that one.
I mean, the grand scheme of things.
Paint was building. Okay, Camden, how do I find where the crossing points are?
Set them equal to each other.
Set them equal to each other. That one?
Or you just solve
Okay, how does it factor?
x minus 2 is plus 1, so x equals 2.
Okay, and that looks reasonable. Sasha, how do I set up the stuff?
You set up an integral from -1 to 2, and it's x plus 1 minus x squared.
Careful with parentheses. If you don't put a parentheses around the second thing, you're gonna forget to distribute the negative. Distributed the negative and added the one to the other existing one. Alex, integrate that. No?
So I have 2x. So be x squared over 2 is 2x minus x to the third over 3.
Gross. So plug in the 2, 2 squared divided by 2, plus 2 times 2, minus 8/3, and then minus positive 1/2, minus 2 plus 1, plus 1/3, 6 minus 8/3, and this becomes negative 3/2, but adding 3/2, but subtracting 1/3 looks like 4.5. Because negative 8/3 minus another 1/3 is negative 3. 6 minus 3 is 3, plus 1.5 is 4.5. Just saying, like, some of you on tests and quizzes make mistakes in the arithmetic, and I'm not a fan of it either. And look for strategies to maybe make it easier. Making whole numbers out of your fractions and stuff. Yeah, Ari. Woo. I didn't think you guys could get quieter than last semester, but you have like the long weekend hangover or something. But is this reasonable? The top minus the bottom, and you've got to find. Okay, you need a calculator, I believe, for the next one. So. The space touch the line.
Oh, here it is.
We made the second part more compact. It's got much
Want the X value of the intersection. So then it's like the wall.
And.
Yeah, that's one of them.
I know there's a way to do it.
Oh wait, and then you can do the inner, wait, can't you do the inner? There you go. And then which one's the?
Goodness, still can't get it.
Which one of the ones is it not? Yeah, it's that.
All right, so if you're not in radians, make sure you are. I'm going to change my window to shrink it down to what I think is more appropriate. All right. And I hear I think there's a way to, okay, yeah, there's a way to. I want to do second trace, which is calculate, and I want to find where they intersect, which is button 5. And the 84 is a little different. This is the 83. Okay. It says first curve, yeah, you're blinking on one of them. Second curve, yeah. And guess. And the 83 goes to the first one to the right. I believe the 84 goes to the one that's nearest. Okay, so there's my answer. Don't touch nothing. Second quit right now. If I type in X, the X value of that intersection point comes up, and I want that. I'm going to hit the STO button, the button above on, store that in alpha A, so that I don't have to type all that junk in. So there's my graph. What do I need to set up to find the area between the blue and the green? Blue and minus the green? Cosine x minus x squared minus 1. From where to where?
Negative that number to positive that.
Okay, so it's symmetric. I could calculate that number again, but it is symmetric. Negative 1.176, 76. Okay. And totally unnecessary, but it does, when you're doing this by hand, make it a lot easier. Because subtracting negatives, you guys, sometimes drop it and make the area become 0, which is unfortunate. I could go from 0 to 1.7 whatever and double it because it's symmetric. All right, I'll show you calculator tricks. I'm going to look, where did I type these again? Top curve, cosine was in Y1. All right. So math 9 is integrate vars y vars function 1 of x minus vars y vars function 2 of x
I'm integrating that from 0 to the thing I stored. And then I need to, oh, bummer. Okay, if you type something wrong, click the go to. Oh, I didn't put in an X. Do you guys know that you can insert? Second DEL is insert. Ugh, and it didn't go. Oh well. There it is. And I needed to double it. So did you guys get 3.113?
Yeah.
Yeah.
Do you have to find it for 0? Like, use the 0? Like, because I just did like, and also the X, I didn't plug in. Like, I just said y1 minus y2 dx.
Let's see. Okay, your 84s can do things differently than this one. I believe my 83, I need the X, I need Y1 of X, because I've had it use defaults that are floating around. I'm paranoid, so I'm making sure it does what it needs to do correctly. But I can also say negative A to A. So using the variable thing is nice on quizzes and tests. If you tell me that that is A, you're allowed to use A, but you need to tell me what it is. Don't be like said child that is on the wall that was like, yep, I did the whole thing on my calculator and I just wrote an answer at the end. When has that ever been okay? So you need to show me something with maybe the numbers that the calculator spit out in the interim, you know? Cool. Okay. Oh. You guys try this problem. You guys try that one. There are years that the algebra is hard. I mean, it's the same algebra. There are years that students find it a challenge. And evidently, it is less fun when it's this guy on the right. They wanted more terms in there. Sorry. These guys got 3 terms. Don't get it. Anyone get an answer for either of the sides? Josh, did you get an answer or you're just agreeing with?
Oh, I got A.
Okay, good. Jasper, did you get an answer? 9.5 or 9 halves? 9 halves. 4.5? Sean, did you finish the other one? Which one? Did you finish the second one? Yeah. Said with like 4/3. I agree. 9 halves and 4/3. That one graphs roughly like that. And that one's roughly like that. So tomorrow, if you notice, I found the full coordinate, the x and the y value, because tomorrow we're gonna do maybe integrate a function like this that isn't a function, and you need to do line bending sideways stuff. Heard that, Alex. How do I get positive area? Right minus left. And the slices, like the reason, skipped over them, but what's the thickness of that little rectangle? Change in y. Ew, 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 ew. So if it's dy, ugh. If it's dy, then everything in here has to be a function of y. So you're gonna have to get x equals blah, 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 blah. And you guys are gonna be allergic to it. And, you know, if you need to turn your paper sideways, you can do that. But this is what we're doing tomorrow. Just wrap your head around it a little bit now. It'll be uncomfortable. Right. So that's all for today.